wavelength which is bigger than ultraviolet. So the shortest wavelength which is used for, yes.
Doesn't ultraviolet can't pass through atmospheric window?
No, some part of it, not all, some part of it is blocked, some part can pass through the atmospheric window. You go to any pharmacy, you will find lot of UV cream to protect your skin from the sunburn. So that burn is mainly from the ultraviolet rays. So that means the ultraviolet rays, they are passing through the Earth's atmosphere. So they are the shortest wavelength which can be used for remote sensing. Radio waves are generally used for communication. Is true or false?
True.
Radio waves, they are generally used for communication. Any information which has to be communicated from space to the earth, radio waves are used. This is true or false? True. Radio waves are normally used for communication. Infrared rays or infrared radiations are visible to the human eyes. We can see infrared radiation, true or false?
False.
False, we cannot see infrared radiation. Okay, in the last class, we stopped at this slide where we were talking about the difference between image and photograph. When we, in remote sensing, generally or frequently, we use the term image rather than photograph. Now, why don't we use the term photograph? Because photograph generally refers only to the visible part of the electromagnetic radiation. So, if you look at the wavelength of the visible radiation, for the violet it is 0.4 micrometer, for the red it is 0.7 micrometer. So, that is the visible ray. Some cameras, they can detect small portion of ultraviolet also and small portions, small wavelengths of infrared also. So generally, any image which has been taken between 0.3 micrometers to 0.9 micrometers, that is called as a photograph. Anything beyond that, means anything which is more than 0.9 micrometer, that will not be a photograph, that will be called an image. So, a photograph can be called as an image, but an image cannot be called as a photograph. Photograph is a part of the image, means the long range of microwave radiations, electromagnetic radiations for which the image can be acquired. Photograph is a small part of that. So, we can use the word image for photograph, but we cannot use the word photograph for an image. Okay? So, we saw this one already. Human vision is a system that is able to detect 3 wavelengths or spectral bands. Our brain combines this data detected by our eyes into a single color image. All of the colors that human perceive can be created by 3 additive primary colors: red, green and blue. All the colors which we can see orange, we can see violet, we can see pink, we can see green, means different colors. All the different colors which we can see, they can be created by mixing these 3 primary colors: red, green and blue. So therefore, color images are actually made of 3 values, one each for the amount of red, green and blue light that enter your camera for each pixel. So by combining these 3 colors, we can create all the different colors. So that means we need a 3-band image to display a color image. Okay? If we are using 1 band, what will be the color of the image? It will be in gray scale, black and white. If we are using 2 band, there will be color, but it will not be the actual color. It will be a false color. Okay? So we need 3 bands to display a colored image. Of course, using the 3 bands also, we can create a false colored image. That is possible. But to see a natural, like here it is there. Okay. These are the 3 bands of image, different bands. blue, green and red. Individually, if you see the images, they are in gray color. Now, if you assign the blue image to the blue band in the software, green to the green one in the software and red to the red one in the software, and when you combine these three, the result is this which you see here on the right side. This is a true color image. Now how can I create a false color image? False color means that is the image will be colorful, but that will not be the actual.
Because green.
Huh? No, forget about 2 bands. 2 bands will be totally wrong. But with 3 bands, how can you create? Can you switch on the lights?
Use the green, sir. Green band.
No, just change the order. Like here, what we do? We assign blue to blue, green to green, red to red. So we create a color image. Now, if this is designated for blue, if I assign this red to the blue and I assign the blue to red, green to green, or any other band combination other than this, it will create a false colored image. But that is not an error. No, in remote sensing, this is the beautiful thing about remote sensing. Some of the, as I told you in the last lecture also, some of the things you cannot see clearly in the true color. Okay?
Yeah.
So if you create a false color imagery, you will very easily be able to see where the some of the things which you may not otherwise see in true color. What happens to the cable every time it is disconnected? Okay, so normally when we are looking at something, are we seeing the thing in black and white or we are seeing in color? We are seeing in color. So all the parts of the visible light, they enter our eyes and it is processed and we see the color image. We cannot separate between red, green and blue, means we are not processing it separately. It's all the light going in our eyes at one time and all the bands are mixing and we see the color image. Means we cannot, even if we want, we cannot see a black and white image. Okay, it will be in color. Of course, if something is black and white, you will see black and white. But if the chair is red and if you want to observe it in black, you cannot do that. It will appear red to you. Until and unless if someone is like, there is a disease called color blindness. Some people, they cannot see a particular color. So in that case, it will be grayscale for them. But normally we see them in color. But the remote sensors which we have, the sensors which are designed in remote sensing, they have this ability to capture very small wavelengths of the electromagnetic radiation. So instead of capturing the whole wavelength, say for example, if we are talking about visible light, it is from 0.4 micrometers to 0.7 micrometers, isn't it? The wavelength for the visible light is from 0.4 micrometers to 0.7 micrometers. So for our eyes we are seeing, or even if we are using a normal camera, if you are using your phone camera, normally all the range from 0.4 to 0.7 micrometers enters the camera, and then the image which you take is a color image. But the sensors, remote sensing sensors, they have this ability to break this big range into smaller wavelengths, and they can take images in different discrete wavelengths. Like for example, you can have one image between say 0.4 to 0.5 micrometers. They can take one image between 0.5 to 0.6 micrometers. They can take one image between 0.6 to 0.7 micrometer. So within small bands of the wavelengths of the electromagnetic radiation, they can take images. So these small ranges of the wavelength, electromagnetic wavelength, for which the images are taken by the remote sensors, they are called as band. Okay? When we say that a particular image is from a particular satellite is a 7-band image. What do you mean by a 7-band image? In 7 different wavelengths, the different range of wavelengths, the images have been acquired. So you will see that, for example, the Landsat, the most popular one, it has 11 bands. That means the images are acquired between for 11 different ranges of wavelength, not one big range of wavelength, but 11 small parts of the electromagnetic wavelength. On the other hand, for example, Sentinel satellite. Sentinel, if you see, they have 13 bands. That means they have 13 small ranges of wavelength in which the image has been acquired. So these small range of wavelength for which the image has been taken, they are called as band. And what is how will a single band image look like? Once again,
Grayscale.
it will be in grayscale, black and white. Single band image will it will appear as black and white. And what will you do to create a colored image? How many bands you will take?
Three colors.
3 bands. You will take 3 bands and you have to assign it to red, green and blue, and the result will be a colored image which you will see. So instead of saying 3 range of wavelengths, we can say that we need 3 bands. So when we are talking about a band of means how many bands are there in a particular satellite image? Someone says there are 7 bands. So what does that 7 band means? The image has been acquired in 7 different range of wavelengths for that entire electromagnetic spectrum. Okay? So the information from a narrow wavelength range is gathered and stored in a channel, also sometimes referred to as the band. We can combine and display bands or channels of information digitally using 3 primary colors: blue, green and red. Any software which we are using to create a colored image, it will have the 3 bands, blue, green and red. Okay? By default it is blue, green and red. Now it is up to me whether if I assign my blue image to the blue band, the green image to the green band and the red image to the red band, then I will get a true colored image. But if I assign any other combination, I will get a colored image, but that colored image will be a false colored image. That will not be a true image. The data from each channel or each band is represented as one of the primary colors, and depending on the relative brightness of each pixel in channel, the primary colors combine in different proportion to represent the different colors. Okay? Now the other thing about the digital images, okay, whenever someone goes to buy suppose you go to buy a mobile phone, okay, and you are looking at the camera, what is the one basic thing normally people look for? Pixel. Okay, if you are an advanced photographer, then of course you will look for many other things, but simple people who are not, means just you want to take picture and don't have much idea about photography, so the one basic thing which people look for is number of pixels there. So normally we assume that if the number of pixels are more, the quality will be better, it will be higher quality. So what is this pixel? Means the pixels, they are associated only with digital images. With have you seen the images in in earlier days there was a film camera, and with the film you click the picture and then you develop it in the lab and you have a hard copy of that. Now in that hard copy image which is acquired from the film, you will not have this pixel thing. This pixel are only associated with the digital photographs. Okay, so a digital image comprises of a two-dimensional array of individual picture elements. Okay, this picture elements, short form of that picture element is pixel. Okay, so you have, for example, this one you have rows and columns, and each pixel will have a value. That value will be for the brightness or how much amount of a particular wavelength of light is reflected. Okay, so the pixels are the basic building block that makes up a digital photograph. Okay, the number of pixels in an image determines its spatial resolution. When we are talking about that a camera has, say, x pixel, x megapixel, so that means we are talking about the resolution of the image, and that resolution which we are talking about, that is called as spatial resolution. When we talk about remote sensing images, there are other resolution also, but when we are talking about pixels of the remote sensing image, then we are talking about spatial resolution, how big or how small the pixel size is. So if the pixel size is small, the image will have a high resolution or low resolution.
No. It's high pixels.
Let's do it. Okay, this is one photograph. This is one. I am talking about individual pixel. Okay, if the pixel size is small. Okay, so this is one. Okay. This is the second one. Where the, okay, this is A and this is B. Where the pixel size is small, A or B? Smaller pixel size.
Smaller B. Smaller pixel.
The size of the individual pixel.
Yeah.
Small
is
B.
Small where?
B.
And where there are more pixels, in A or B? B has small pixels and B has more pixels.
Yes.
So normally when you are talking about this mobile camera or something, you say what is the how many pixels are there? So okay, it has 50 megapixels, or a camera has 30 megapixels. So when we are saying 50 megapixel or 30 megapixel, means in the same area two cameras are there, one is having 30 megapixel, the other one is having 50 megapixel. So in the same size, same area, one is having 50 megapixels, one is having 30. So that means 50 megapixel, each pixel is small. So that is why you can fit more pixels inside. So if you have more pixels, smaller the pixel size, higher is the spatial resolution. Bigger the pixel size, smaller is the spatial resolution. Means here the pixel size is small, but if you look at the total number of pixels in this image, the number of pixels are more. So when we are talking in terms of remote sensing, we generally do not talk in terms of the pixel resolution like we talk for a mobile camera or a general photo camera. I mean, in remote sensing, we talk about the individual size of the pixel. So, for example, the image which is acquired from Landsat satellite, it has a spatial resolution of 30 meters. Okay? Image which is acquired from Sentinel satellites, they have a resolution of 10 meters. What do you mean by 30 meters and 10 meters? In Landsat, one pixel size is 30 meter by 30 meters. Size of one pixel. Now we are talking about size of one pixel. Okay? And in case of Sentinel, one pixel size is 10 meter by 10 meters. So which one do you think has a higher resolution? Landsat or Sentinel? 10 meter will have a higher spatial resolution, because then you can see smaller objects also clearly as compared to the one which has a 30 meter. So when we say that the spatial resolution is 30 meters, the spatial resolution is 10 meters, the spatial resolution is 1 meter, that means we are talking about the pixel, individual pixel. What is the size of the individual pixel? So smaller the size of the pixel, higher is the spatial resolution. More details you can see. Yes? Yes, more means more clear photograph image you can see. The number of pixels in an image determines its spatial resolution. So higher resolution images, they have more pixels per unit area, resulting in finer details and clarity. Okay. Then you have something called a digital number which is associated with each pixel. Now if you are talking about a grayscale image, okay, and it is an 8-bit image, 8-bit image means 2 to the power 8. If you talk about a 1-bit image, how many colors will be there in a 1-bit image? If it's the grayscale, 2 to the power 1. 1-bit image means you will have 2 colors, black and white, no other color, black and white. Clear as that, like you have this below, you see PC9, PC8 written on that
Yes,
paper.
black and white.
You see only 2 colors, black and white. Okay, but as you increase the bits, okay, so if you go to 2-bit image, that means 2 to the power 2. How many colors will be there?
4.
2 into 2, 4 colors will be there. If you have a 4-bit image, it will be 2 to the power 4. So the number of colors will be 16. Okay, 2 into 2 into 2 into 2. Now if you have an 8-bit image, you will have 256 colors. So it's a grayscale image. It will start from 0 and it will go up to 255. Higher the reflection, bigger will be the value of the digital number. Lower the reflection, the lower will be the value of the digital number. So you have this pixel element, each pixel has a digital number, a value which corresponds to the color. So that means if the value is 0, what will be the color? Black.
Black.
0 will be black. And if the value is 255, what will be the color?
White.
It will be white. 255, for example, you see here 255 is written here, and 255 corresponds to this one. This is white. Okay. On the top one, you see it's written 0. 0 is black. What about 50? If it is written 50, it will be close to black or it will be close to white? Close to black or white? Close to black, it is 50. If I say 150, then where it will be? Close to black or white? It will be closer to white. 200 more closer to white, 225 almost white, 255 is pure, absolutely pure white. Okay. Similarly, the values means as you decrease from 255, go towards 0, it will become darker and darker. And what is that light and dark showing? The amount of that particular wavelength which is reflected from the electromagnetic radiation reflected from that particular surface. If the reflection is more, the color will be close to white. If the reflection is less, that means there is more absorption, the color will be close to black. Okay? So each pixel has a value associated with it. Now it depends, means you are talking about pixel in which term. Now here we are talking about the pixel of an image. Okay? If you have studied GIS, you can you know what is a digital elevation model. It tells you about the elevation of the land surface. So where you have the high areas, where you have the low areas, and so on. So you must have heard about digital elevation model from SRTM or ESTER. Okay.
Yeah.
Now, for example, you talk about SRTM, elevation data from SRTM. It has a 90-meter resolution. What do you mean by 90-meter resolution? Each pixel is 90 meter by 90 meter. Now, what information will be there in the digital means? You have the pixel size, okay. This is 90 meter by 90 meter, okay. Now, in this one, this was an image. In this one, the information which is contained here, this digital number which we see, it corresponds to the amount of electromagnetic radiation which is absorbed or which is reflected. So, if I am using any remote sensing software and if I zoom in and I click on each one pixel, I will get a value which is the digital number, and that will correspond to the amount of radiation which is reflected. Now if I take a digital elevation model, if I zoom in GIS and click on one pixel, it will also contain a digital number, it will also contain a value. What will be that value for? Suppose I click on this pixel and it says a value of 300. So what does it mean? Is it showing color or is it showing something different? The digital elevation model, what does it show? The elevation. So the value contained in this pixel will be about the elevation. So that 300, that means 300 meters above sea level is the elevation which is stored in this particular pixel. So when we are talking about pixel, here we are talking about pixel of an image. Here we are talking about pixel of the elevation model. So this elevation model pixel, the digital number which is assigned to this elevation model, it will tell you the height above the sea level. So 300, 400, 500, what it can have, any value, okay, depending on how high or how low it is there. Okay. But in terms of image, if you are talking about the digital number, in terms of a remote sensing image, then the value which is stored here, that corresponds to the amount of that particular electromagnetic radiation which is reflected from the surface. If there is no reflection, the pixel will be black, the digital number or the value will be 0. Okay? If the reflection is very high, very strong, then it will be close to 255. So in the grayscale image, and also means this is what is shown here, means 256 colors will be only for the 8-bit image. If you have a 16-bit image, then it will increase, it will become very high. I think around 65,000 something colors are there approximately in 18-bit image. 16-bit image. But what is written over here, this is about the 8-bit image. In 8-bit image, you will see 256 colors, and if the image is a grayscale image, black and white image, 0 will be for black and 255 will be for white, and anything in between that will be, if it is more dark, it will be close to 0, if it is more white, it will be close to 255. Okay? So the basic element of the remote sensing images are these pixels, and all these pixels have an associated number with them, which we call as digital number, which shows the amount of electromagnetic radiation which is reflected from the Earth's surface. Okay, so I think this is the last slide of this one, this unit. So we finish with unit 1. Okay, we learnt about the electromagnetic radiations, the source of electromagnetic radiation, what happens to the electromagnetic radiation when they pass through the atmosphere, what happens to the electromagnetic radiation when they reach the Earth's surface, okay, and then we discussed about the atmospheric window, which part of the electromagnetic radiation can pass through the atmosphere, which cannot pass through the atmosphere, and then we talk about pixel and what is the difference between an image and photograph. Okay. Now let us start with the next unit, unit 2. I shared the link with you. Did you download it?
Yes. It's all.
It's working good.
Yes.
Now in the second unit we will be talking in details about the sensor and the characteristics of the sensor. Now what is the, to repeat once again, what are the two things without which you cannot do remote sensing? Two things without which, yes,
Sensor and tongue.
sensor and
The tongue.
what about electromagnetic?
The source of the
So, that means electromagnetic radiation is the first important thing. If you do not have an electromagnetic radiation, there will be nothing which can carry the information. Okay? So, first important thing is the electromagnetic radiation. And the second important thing is the sensor, which can record that particular electromagnetic radiation. So, therefore, sensors are the most important thing, means after the electromagnetic radiation, sensor is the most important thing. And what does the sensor do? Sensor, it records the reflected electromagnetic radiation from the Earth's surface. Now when we talk about sensors, we also talk about platforms. Okay? Sensors and platform, they are associated with each other. Now what is the difference between a sensor and a platform? Okay, now your phone is there on the table or chair. Okay, if you want to take an image from that phone or picture from that phone without touching it like that, can you take? No, what will you do to take the image? Touch it means you will have to hold it in your hand. Okay. You can take a picture like that also if you have like Bluetooth or something, but it will not be, means if you want to take a picture of me, you cannot do like that. You have to hold it in your hand and then you have to face it towards me and then you will take it. So that means the phone, the camera in your phone is your sensor, okay? And the hand means you held the phone in your hand, okay? Now the hand, it becomes the platform, okay? Or in some cases you can have a camera stand, you put the camera on the stand and then take the picture. So anything which provides stability to the sensor, that is called as a platform. Means the sensors, they cannot work on their own. There should be something to which they are attached, okay? And that thing to which they are attached, that is called as the platform. You have the speed, not the speed camera, the camera at the traffic signals, for the red light. You have at some Sahar cameras, you have, so where is it kept on the ground or it is attached to something?
No, it was
The speed camera, they are kept in a box on the side, but the one for the red light, it is attached to something. No? There is a pole, and to that pole the camera is attached. At some places you have camera for this seat belt and for mobile phone. Where are those cameras attached?
Attached and
You have the signboards on top, and on the top that signboard, they are attached to that. So it's not hanging in the air, it is attached to something. Okay? So that thing to which that camera is attached, that is called as a platform. Okay? Now you have a drone camera, for example. What is the platform in case of the drone? Means you have a drone, and on the drone you have the camera which is attached. So that drone, it is the platform which is providing stability to that sensor. The sensor is the camera. So, or for example, you can have a hot air balloon. Okay, hot air balloon. You attach a camera to that hot air balloon. The balloon will go up in the atmosphere, and the camera which is attached to that balloon, it will take the images of the Earth's surface. So what is the balloon? Balloon is the platform. The camera is the sensor. Similarly, you can have a camera which can be attached to a plane, aeroplane. Aeroplane is moving and the camera is attached to the plane. As the plane moves, it takes images of the Earth's surface. So the camera again is the sensor, and the platform in this case is the aeroplane. So anything which is providing stability to the sensor, that is called as a platform. Now we talk about satellite. We have the satellite over here. Satellite is the sensor or is it the platform?
platform or
That's
sensor.
all. That's all.
Both.
Some are saying platform, some are saying sensor,
Both.
some are saying both. No, actually satellite is the platform. And on one satellite you can have different sensors which are attached. Okay, each sensor will have a specific objective or specific target, specific capability. In one satellite, on one satellite you can have different types of sensors which are attached. Now, the objective of the sensor is to acquire the images. Satellite is already providing stability to the sensor, but satellite, since it is moving in the space, the sensors are designed in such a way that means at that speed at which the satellite is moving, they can capture images of the Earth's surface. So basically, the satellite is the platform, and on that satellite, on one satellite you can have different kinds of sensors. Means normally you will see that one country is launching a satellite, and on that satellite you have sensors which are there from different countries. It is not necessary for everyone to launch a satellite along with a sensor. Okay, I know that, okay, that person is launching a satellite, I have my sensor, I can request him, he can attach my sensor on his satellite as well. So sensor will be taking the images, and satellite is the thing which will be providing stability to that sensor. Now we discussed three kinds of things. You said in the beginning that Saher camera, they are attached to the pole. Okay, a drone camera, which it is connected to the drone. Okay, or a aeroplane camera on an aeroplane, it is attached to that aeroplane, and the sensor on in the space, it is attached to the satellite. So based on where your sensor and platform is situated, you can have three different types of platforms and sensors. What are those? First one, Saher camera, where it is? Is it in the air? Is it in the space? Is it on the ground? It is on the ground. The platform, the pole, it is fixed to the ground. On that ground, on that pole, you have the camera which is attached. Sometimes you can have a camera attached to a crane also. Okay, so crane is where you know what is a crane, that long thing with which you lift things and all.
Yes.
At construction site, you will see a lot of cranes are there. You can see here also, outside you have a lot of cranes. So if you attach the camera to that crane, what kind of platform will it be? Will it be space-based, air-based, or ground-based? The crane is present on the ground, isn't it? It's a high crane, but it is, the base is on the ground, and the camera is attached to that crane. So that is a ground-based platform, and since the sensor is attached to that ground-based platform, it will be called as a ground-based sensor. What about the drone? Where it is? Is it in the space or air or ground? Air. It is in the air, and the camera is fixed on that drone. So which kind of sensor it is? Is it air-based or space-based or ground-based? That will be called as a air-based sensor and air-based platform. Okay. Or you can sometimes also call it as atmosphere-based platform or atmosphere-based sensor. Now what about satellites and the sensors which are attached to the satellites? Which kind?
Space-based.
They are the space-based sensors and space-based platform. So depending on where the sensor and platform pair is situated, you can have three different kinds. One is the ground-based sensor and platform, then you have the air-based sensor and platform, and then you have the space-based sensor and platform. Okay. Now, which do you think is the best one for taking? Okay, rather than talking about best one, which of the three, ground-based, space-based, and air-based, which of the three will give you the largest image or biggest coverage? Space-based, because it is high up in the air, almost 500-600 kilometers above the surface of the Earth, so the coverage will be huge. Means it's as simple as that. You are standing on a first floor building, you see some area of the ground outside. If you go stand on Burj Al Mamlaka, you will see whole of Riyadh standing from there. The area will increase. So the higher you go up from the ground, the more the coverage you can see. So where will you see the minimum coverage? Ground-based, air-based, or space-based? Minimum, smallest.
Ground based.
Ground-based. It is closest to the surface, so you will see the smallest amount of the smallest area will be covered by the ground-based, then the air-based, and then finally the space-based. Now, depending on your objective, you will choose which kind of remote sensing you want. Also, there are some advantages. For example, if you have a ground-based sensor, it is very close to the ground. So, whether there is strong wind, whether it is raining, whether there is a dust storm, ghubar, it will not affect the quality because the sensor is very close to the object which you want to image. So, it will not be affected by the atmospheric disturbance. But on the other hand, if you talk about atmosphere-based sensor, for example, a camera attached to a hot air balloon or a drone camera, if the weather is not okay, if it is windy, if it is raining, you may not be able to use the flight, okay, it will be disturbed, so it will be affected by the atmospheric disturbance. The ground-based sensor will not be affected by the atmospheric disturbance. The space-based, okay, it can be affected, it will be affected by the atmospheric disturbances like rain or clouds, it may not be able to cover, but since it is much above the atmosphere, so means the atmospheric winds or other things will not disturb or affect it. Which one do you think is the cheapest one? Which will be more expensive? Ground-based is easy, means you stand up on a height and you take the image of the earth's surface, so it's very easy, you don't require a lot of specialized equipment for that. And the most expensive one will of course be space-based. You have to launch the satellite in space, specific kind of sensor will be attached, so it requires like sometimes even billions of dollars are required to send one satellite and sensor in the space. So they are of course the most expensive. But of course the satellite which is sent in the space, it does not remain in the space for 1 year or 2 years. It has a long lifetime. It may stay in the space for 10, 15, 20 years depending on the life of that particular satellite. Time is over?
Yes.
Okay, so we will continue with this one in the next class.